Assalamualaikum warahmatullahi wabarakatuh. Well, today I'm going to explain the research that we conduct together entitled Monthly Rainfall Prediction using Vector Autoregressive Models based on ENSO and IOD phenomena in Cilacap. We conduct and carry out the research together with the Department of Mathematics, Andalas University in West Sumatra. The authors, me as a first author, and Motia, Dodi, and you can see the remaining authors. Let's continue. Okay, for introduction, based on the data on disastrous events in Indonesia from 2001 to 2019, issued by National Disaster Mitigation Agency (BNPB), it is known that Java Island, especially Central Java Province, is an area with the highest hydrometeorological disaster. Hydrometeorological disaster events, both floods, landslides, and strong winds. And also the spatial distribution of disaster event, especially for floods. Um, it is known that the most dominant area experiencing flooding is Cilacap. You can see it can be seen here that spatial flood distribution of flood events in Central Java. Therefore, it is necessary to predict rain in the Cilacap area as an effort to mitigate disaster in the area. We try to forecast and analyze the forecast of rainfall by using VAR model. And what's the VAR model itself? The VAR, the factor autoregressive model, is an extension of the autoregressive AR time series model with more than one variable, where all variables in the VAR model are assumed to be endogenous variables whose values are determined by other variables in the model and are interconnected. Here, the general form of the VAR model with like B, VAR B can be stated as follows. We refer to the research conducted by Wei in 2006, and this is the variables D. Okay, data operation of vector autoregressive VAR model using daily data and monthly data. Okay, the description first description. For rainfall in Cilacap, iodine anomaly and ENSO anomaly for the monthly period starting from March 2000 to December 2018. It can be observed from the picture, the monthly data, that a 3-time service data still fluctuate randomly and do not move around a fixed value. That is, the street data must be stationary with respect to the variance and mean value so that data fluctuations are more oriented at a certain interval and the movement is centered on a fixed value. And also, it depicts a graph of rainfall time series. We found that 3-time series data, fluctuate randomly. So data are more directed at a certain interval, and movement is centered on a fixed date. Okay, this is the stationary. We try to do the stationary because we believe that the problem of fluctuation in the data, therefore a box Cope's transformation is needed to overcome the problem of stationary variance and the differencing method to make the time series data move at mean value. Okay, next we carry out to selecting the best order. Determination of the optimal number of flags can be determined using the IK information criterion. or AIC, and SC, final prediction for FPE, or Hanan phenomenon. And from here, we can observe that the lag 2 is really dominant, and we try to select the best order is lag 2. Okay, this is the VAR or rainfall IOD and so this is the estimation. And for the detail, all of you can see that rain, IOD, and ENSO are quite um, identical because they are fluctuated and interconnected one another. Next, we have orthogonal impulse response from IOD and so in this figure, there are fluctuation in rainfall intensity in the first month of stability, and then a fluctuation occur until the 5th month, which then stabilizes in the 5th month and so on. While the IRF from ENSO for rainfall, it can be seen that there is a fluctuation on the 2nd day and in the following month as well. And also, there is a fluctuation on the 2nd day, as I said earlier, and in the following month, there is a stability at the equilibrium point. And this is the actual and forecast. We see that the figure indicates that our model estimation is able to evaluate the performance of those three data. Moreover, the relationship between VAR model estimation and observation is significantly strong for ENSO and IOD data in particular. Somehow, VAR model only predicts a narrow range in terms of a middle value only. In other words, the VAR model is not able to predict both the highest and the lowest peak of rainfall compared to observation data. And we have here the VAR model accuracy for rainfall, the RMSE, root mean square error. We found that 87.0 assays, and for mean absolute percentage error, we obtained 0.329. It indicates that the performance is quite good. And for the IOD and ENSO, on the other hand, the RMSE, mean square error, we found 0.184 and ENSO 0.21. Actually, comparing to rainfall, performance of IOD and ENSO are more accurate. It means that the VAR model accuracy goes, the good VAR model accuracy goes to IOD and ENSO. And this is for forecasting. We found that the following month, it can be clearly seen that those three data are in, within the range. For the bottom and highest peak for the top range. So we can conclude that the forecasting is really able to predict. Okay, this is the interval of our model prediction. We can observe that the range is within the lower and upper. So we can say that the research is completely successful, but we need to conclude first. Rainfall in Cilacap is predicted to be stable and within the prediction range in the upcoming periods. Similar trends are also observed for the IOD and ENSO, where the predicted data is not beyond the lower and upper forecasted values. And the aforementioned statements indicate crystal clear that a VAR model performs well in forecasting the IOD and ENSO, and is fairly moderate in predicted rainfall in Cilacap. For getting better results and more supporting evidence of this performance, however, it is suggested to further carry out of this study in predicting rainfall IOD and ENSO in other areas in Indonesia. That's all for the presentation, and thank you for the attention.